want to talk about Puppet at Spotify and like configuration management in general, but we're a Puppet shop, so that's what we're using for configuration management. I mean, most of you probably know what Spotify is, I guess. But just to give you some sort of numbers and about what scale we're operating, we have over 24 million monthly active users. And we're launched in 28 countries at the moment, with over 20 million songs in the catalog. And we have more than 1 billion playlists in our system. And all these numbers are growing very, very quickly. We're rapidly launching in new countries and also growing quite a lot in the countries where we're already launched. So that, of course, poses a lot of technical challenges to scale our backend systems in the same pace. And I mean, we're also growing in terms of people working at the company. And that, of course, also poses a lot of challenges with like scaling workflows and that sort of stuff, and communications within the company. And so at the moment, we have tech offices in New York, in Stockholm, and San Francisco, and Gothenburg, where the Stockholm and New York offices are the biggest ones. And there's where we have most of the infrastructure people. So who am I? I'm working as a system engineer in our site reliability engineering team in the Stockholm office. I'm the operational system owner for Puppet, and that's where I spend quite a lot of my time, actually. But I'm also operational system owner for our playlist system and our Cassandra databases that we use quite a lot for many different backend services. And I'm also a community contributor to Puppet and as the open source project. At Spotify, we've been using Puppet for around 3 years now. We started out fairly small with just porting a few things to Puppet. I think monitoring was one of the first things, like in statistics gathering. That was before I started at Spotify, actually. But before that, we used a system called FI, fully automated installation, with kind of, as far as I know, Debian-specific system, which basically runs a bunch of shell scripts and kind of configures the servers for you, and so you can boot up servers, and it does a bunch of stuff using shell scripts. But we gradually migrated away from that and to Puppet, because it got us a lot quicker turnaround time with making config changes and that sort of stuff. Probably like a year ago or 1.5 years ago, we migrated like fully away from FI, and since then all the configuration is done by Puppet. So when we install new machines, we just do a very minimal basic Debian installation, and then Puppet does all the rest of the stuff. Some things that might be a little bit different to how we use Puppet compared to how a lot of people use it is that we allow, all the application developers to develop their own Puppet modules and that sort of stuff. So we have quite a lot of changes in our Puppet code base. It's roughly 450 non-merge commits per month on average. And we don't have any kind of weekly maintenance downtimes or anything like that. So once a change goes into the repository, it immediately goes out to the entire, like all the machines, within half an hour, at least. It's 220 different people that have committed code to our Puppet manifests. And our traditional kind of operations team is only about 25 people. So there's a lot more people than just the operations that have committed code to this. And there's 325 different Puppet modules. So it's for all kinds of different backend services that we're running in our backend. But I mean, also for a lot of shared modules that are either shared by many backend systems like Postgres or Cassandra modules, but also a lot of them are shared across every single system. And at the moment, this is in one big Git repository where we're using Gerrit for code reviews. So anyone can make a change, and then they can send it to Gerrit for code review. And at the moment, that has to be reviewed by the SRE team before it's merged. So at the moment, we're managing roughly 5,500 nodes using Puppet. And this is across 3 different Puppet installations that are, we have one installation which is we call IT Puppet, which is basically for laptops and desktops. And that's using an entirely separate code base from, like, in regards to Puppet manifests from the rest of the servers. But we use that to deploy a lot of like network policies, like network authentication certificates, just printer settings, installing some applications across all the laptops and desktops. We used to do it only on Mac, but now we do it both on Mac and Windows. And then we have one Puppet installation for the production environment and one Puppet installation for our testing environment. And they're sharing the same code base, so we're running exactly the same Puppet manifests in our testing environment as we are in the production environment, and they're on the same Git branch, the same like Puppet environment. So we're not really like staging the changes in the testing environment for like a fixed period of time before moving them to production. A lot of them are rolled out at the same time in both of them. You can test changes on like individual machines though, before you roll them out to all of the machines. And each of these 3 Puppet installations have their own certificate authority, their own PuppetDB instance. This is a screenshot here from our production PuppetDB instance, so you can see that it's handling quite a lot of different resources that it's managing across our servers. But there's also a very large resource duplication, so I mean, a lot of it is very similar across different servers. We have at least one Puppet master in each data center because, I mean, the Puppet protocol is pretty chatty on the network, so you want to have good low latency to speed up the Puppet runs. So we have at least one in each data center, and then like Gerrit is just push replicating out the Git changes to all of them. And then we run Puppet on all the machines using cron every 30 minutes. So there's no we don't use the long-running agent process. It just does one run and then exits. Some special settings on the Puppet masters that we do that might be worth mentioning, which is a little bit for scaling and so on, is that we do some caching of the file metadata requests. Might be a bit technical with Puppet, but basically with Puppet, if you specify a file resource and the Puppet will, when the agent runs, it will check that that file on disk is the same as it is on the master, and then it will fetch the checksum of that file from the master for each file resource in the catalog. And each of those checksum requests, there's quite a lot of them for each node, and each of them, of course, hits then a Ruby worker process and so on. So that slows it down quite a lot. So we're caching a lot of that in the Apache layer to just avoid hitting the Ruby layer for a lot of them. So in the production environment, they are cached for 5 minutes. That speeds up the Puppet masters quite a lot. But on the other hand, we're using another setting to only do one compilation per worker process. because Ruby definitely has a bit of problems reloading code from disk and that sort of stuff. So if you're using like Puppet plugins and custom functions, that sort of stuff, they're not really properly reloaded between different compilations within the same worker process. So you can get kind of strange scenarios where, if you push out a new version of a custom function, some workers will have the new version, but some workers had already loaded the old version and won't really reload the function. So that's where we're just doing one compilation per worker process. We have a kind of wrapper script around Puppet, which we call SP Puppet, just Spotify Puppet basically. It's just a short, small shell script, but there you can specify what Git branch you want to run Puppet against. So each Git branch in this Git repo is mapped to a Puppet environment. So like when Gerrit does a push replication out to all the Puppet masters, there's a Git update hook that just checks out each Git branch into its own directory on the Puppet master. And those directories are just mapped to Puppet environments. So the agents on the hosts can specify what Puppet environment or Git branch essentially that they want to run against. So that's the method we're using for like allowing testing. So I mean, I mentioned we need code review for submitting to the production branch, but any developer or operations people for that matter can push against a feature branch. And then they can run Puppet on one of the servers against this feature branch, see that it does what they expected and works correctly. And then when they're satisfied, they can push those changes for a code review and to be merged into the production branch. And that's very useful, definitely. I mean, we abuse it for some other stuff. Sometimes we kind of abuse it for doing gradual rollouts of new configuration. So you can like gradually switch hosts to run against a different Git branch. And then once you've rolled it out to all the nodes in a cluster, you can merge it into the production branch and switch them all back to run against the production Git branch. I mean, it wasn't really meant for doing that, but that's one way we use it as well. So it's a bit, has many uses. Let's kind of fetch my water. So with our backend services and a bit about our kind of backend infrastructure, a brief overview. I mean, we're running Debian on all our servers. So it's fairly homogeneous, the server fleet. All our backend services are currently built as Debian packages. So we're just using the regular like package resource type in Puppet to deploy them. I mean, apt as distribution mechanism for that, which I think works pretty great. I mean, it has some drawbacks, but I mean, apt and so on has built-in like caching, checksumming, signing, secure delivery, and etc. So you get a lot of that for free when using that. And each backend service does like, we have a lot of different backend services deployed, and they all do like one tiny little feature of the whole system. So when a client connects to Spotify, it connects to a service we call access points, which are basically the only ones that are exposed to the internet. And it does a authentication, so on. And then after that, they basically work as a proxy for contacting the rest of the backend services. And they do like load balancing and that sort of stuff. So, I mean, the client sends requests to say like, I want to fetch this track or fetch this playlist. And then the access point will do load balancing or like discover what playlist nodes are available or that it should talk to in that specific data center. And then contact one of them and send a request there from the client. And most of these backend services are entirely stateless, so we can scale them up as we need to. And a lot of them are, I mean, they need to store the state somewhere, so we're using mostly Cassandra for database storage, but also PostgreSQL in a couple of them. And then Sparky, which is kind of a on-disk index that we use in some services. It's an open source project that we've developed at Spotify and open source fairly recently. So you might want to check that out. But that's used in some services that are like kind of index-based, that have like a daily index update, kind of like search, for example, where there's a new like search index distributed every now and then otherwise it's very like read-heavy service. So it's not a like traditional read-write database. I mean, this picture here is, of course, simplified. I mean, you can see that like some of the backend services, of course, connect to each other. So they might not do like the entire thing they need to do in the same backend service. They might just connect to other backend services for some parts. But sometimes those other backend services might exist in other data centers. We don't have every backend service in every data center. But I mean, mostly we try to deploy the ones that are like latency critical and the ones that are needed to keep the core functionality up, like actually playing music. But all the other like kind of extra features aren't deployed in every single data center. And most of our backend services are implemented in Python, but quite a few in Java as well. So when we want to deploy a new backend service, this is a very simplified list, by the way. There's a much longer checklist, actually. But we have the feature team that developed the backend service write a Puppet module for it. And then they deploy and test that Puppet module in the testing environment. And I mean, when they're usually like develop the Puppet module as they're developing the service, even I mean for deploying the development environment of that service. And then when they're happy with it, it's merged to the production branch. They request hardware from our SRE team, and then we just tag them with those classes that they developed and deploy it in production. So for service discovery, we're using, I mean, I mentioned that the access points try to like discover what backend services they need to talk to. Of course, the other backend services that contact other backend services need to discover them in some fashion as well. So we're using regular DNS SRV records for that. It works. I mean, it's pretty simple, but works very well. DNS is a very robust system, definitely. And we're using that for Puppet itself as well, for discovering, I mean, for the Puppet agents to discover their closest Puppet master. We're using the SRV records, and that does like load balancing between the different Puppet masters as well, as you can set different weights and priorities on them and that sort of stuff in the SRV records. I've also created a Puppet module to do DNS lookups directly in Puppet manifests. It's on GitHub and the Puppet module Forge. And we use that sometimes. I mean, there's certain cases where some systems don't support SRV records, for example, or we might need to embed like lists of hosts in config files or that sort of stuff. I mean, for example, with PostgreSQL, you might need to embed a list of IP addresses that should be allowed to connect to the database. So then it can do a SRV record lookup and fetch the list of all the service nodes that's going to talk to it, and just put that into the config file. And then for node classification with Puppet, that's a little bit of a mess at the moment, to be honest. As I mentioned, we have 3 different Puppet installations, and they're all using different methods for node classification, which is definitely something we want to move away from doing. In IT Puppet, we're using the Puppet dashboard. But in our production environment, we have a home-built inventory system that we're using as a node classifier. And in the testing environment, we're using Hira, which is this like data lookup mechanism from Puppet to separate your data from your Puppet modules. And we're planning there on switching to using Hira in the production environment as well. I mean, with Hira, you can specify different like hierarchy levels, so you can do things. It has like you can have different directories and different files based on like this is a node-specific piece of data, or this is for a certain DNS domain, or for an entire site, or that sort of stuff, or for different versions of Linux, for example. And there we can, tag classes on groups of nodes instead of doing it just individually on each node, which we're doing at the moment. So as part of that, or well, for other reasons as well, but we've adopted a host naming standard where basically we have the site of the host, the role that it has, and a kind of pool identifier and a number for each host. We actually used to have female names on all our servers up until we had almost 2,000 servers. Then we pretty much ran out of names. And they became very strange, the ones on the new servers. So yeah, if you have that naming schema, you might want to move away from it before you reach 2,000 servers. But yeah, now we've moved to this new naming convention. And each part of this host name is available as a custom fact in Puppet. So, for example, the role here in the middle, that's part of the Hira hierarchy, and that's probably where we will be classifying nodes most extensively, as generally within the same role type of hosts, you want the same Puppet classes. So we've made a bunch of contributions as well to Puppet and tools around it. So talk about them a little bit as well. Over the past year, we've contributed 25 different patches to the upstream projects. A lot of them are bug fixes, but there's also a bunch of new features there that we've contributed. We haven't been able to open source that many like actual Puppet modules and that sort of stuff. A lot of them are very Spotify specific at the moment, but we're moving a little bit more to using like upstream common modules for common stuff like Apache and Postgres and that sort of stuff. So then it should be easier to open source some of our other modules that if they build on the common Apache modules instead of the Spotify-specific ones. But we've made some pull requests and patches also, and improvements to some of these upstream modules. We're using PuppetDB, as I mentioned. That has a great, that stores all the catalogs and all the facts from nodes after the Puppet Masters compiles them. And it also can also store reports and events on what agents have been performing on these nodes. It has a very flexible query API, so you can query for nodes with like certain resources in their catalogs or where the facts match certain values. And it can do like subqueries between these different things. But it's doing these queries in a JSON array format using Polish notation. So they're kind of complicated to write. They can look like this, for example. So to make it a bit easier to query this system, we made a module called PuppetDB query, which allows you to write much simpler expressions. That top query, the class Cassandra version 1.1 and site equals London, that's the same query as it was on the previous slide. But it does like precedence, so you can and or, and you can use parentheses and that sort of stuff, and search for mix queries for facts and different resources. I mean, not only classes, you can search for like file resources where the owner of the file equals this or that sort of stuff, and mix and match any way you want. It can do regexp searches, so like whether a fact matches a regular expression and that sort of stuff. And that's available as both Puppet functions, so you can query this type of stuff inside Puppet manifests. But it's also a Puppet face, so you can, which is like a kind of Puppet sub-application, so you can query on the command line like this and get lists of nodes or get the facts for them. It's also a Hira backend, so when you're like externalizing data, if you don't want to write like lists of nodes in your YAML files or JSON files, you can instead write a PuppetDB query that returns a list of nodes. And then that will be returned by Hira. And that's also open sourced and available on GitHub. You might notice a trend where they're available. With PuppetDB, we've also made a PuppetDB data mapper adapter. So data mapper is a object relational mapper for Ruby. So you can use it basically like the object relational mapper in Rails, the active record. But it's kind of similar to that. So yeah, you can do these kinds of searches. I mean, that will print all the facts for a certain node, but it can do a lot more complex searches than that as well, which might be interesting if you want to build some sort of Ruby GUI, web GUI or something like that on top of PuppetDB. Another tool we made is Puppet LS, which is a very simple tool really, but it can list all the files in a directory that are managed by Puppet, and which file manages them, and how they got the content, if it's from a content parameter or a source parameter. So yeah, when you're on an agent node, you can just check which files Puppet is managing. It's not intended to make it like, it's not safe to edit all the other files by hand, of course, but yeah, if you want to do that, you can check which ones Puppet are already managing. We've also made a basic Puppet Forge implementation, which is it's a very simple implementation of it. It doesn't have any fancy web interface or anything like that. But I mean, at the moment, the Puppet Module Forge is only available as like the public service there. The source isn't available for it, unfortunately. So if you want to deploy a Puppet Module Forge locally on your site, there has been no real way to do it. But with this, you can do that. It's a very simple implementation. It only supports the necessary APIs for like installing and downloading modules. But it doesn't require any database backend, so it just reads the module files from disk and allows you to install them. And I mean, the Puppet module tool, that's like, I mean, it builds kind of packages out of the modules, and they can contain dependencies to other modules and their versions. So it also handles like dependency resolution between different modules. So if you have a website that might depend on the like Puppet Labs Apache, you can just install your website module and it will correctly fetch the Puppet Labs Apache module as well. And that's also available on GitHub. But a bit about the future. I mean, we're facing a lot of scaling challenges at the moment with this. Not really with like scaling the performance of the Puppet Masters. It's quite easy to just deploy more of them, so that isn't a huge problem at all. But the workflow, our current workflow, definitely isn't scaling to the amount of users that we have using Puppet. I mean, as I mentioned earlier, we require SRE review for all the code changes, and they're all in one big repository. And that's becoming a bit of a bottleneck, as we're only 25 people in the SRE, and we can't really review all the changes. And for a lot of them, I mean, frankly, we don't really know that much about the changes. I mean, the application developers, if they're changing some config file for their own application, they know that stuff much better than we do. So I mean, as we're also moving more and more operational responsibility out to different feature squads that are developing these services. And as part of that, we of course want to make them, we want to make them review their Puppet changes instead of having the SRE team reviewing them. So, so as part of that, we're thinking a bit about splitting the repository out into basically one Git repository per Puppet module. But we don't want to make the workflow too tedious, of course. As I mentioned, we have 325 different Puppet modules, and for example, using Git submodules or something like that would make it probably very cumbersome to work with. So we've been thinking about a bit about some different ways to deal with that. There are some available tools like R10K or Librarian Puppet that can handle a bit about that. They can basically, you can write a kind of manifest which modules you want installed, and then they take care of fetching all these Git repositories and installing the modules into the correct place. But we've decided to develop our own tool there, which I'm going to get into a little bit. But some other things we would like to do is to be able to use masterless Puppet, building images and that type of stuff. At the moment, there's definitely some dependencies between the Puppet masters and this like inventory system that we have. It's trying to fetch a lot of information from there, so they're a little bit tied together, which also makes it quite difficult at the moment to use like Vagrant, for example, and test our backend services using Vagrant. And that's definitely something we would like to be able to do. And also, I mean, for example, using that for automated testing. At the moment, we don't do that much in terms of like RSpec Puppet or RSpec system or these kinds of automated tests. And we would like to be able to, yeah, for example, have the CI system spin up Vagrant boxes and run automated tests against them and see that the Puppet modules actually do what they're supposed to do and work correctly instead of having kind of manual testing as it is now. But with this system that we've been developing, that I mentioned, we called it Spikor. It's named after this He-Man character. Basically, the problem with these tools like Librarian Puppet or R10K is that they only allow, like, I mean, you specify which version of each module should be installed, and it will install all of them into the environment, and then still all the nodes runs against this Puppet environment. But that means that if you want to make like a backwards incompatible change or a change in the API, for example, with defined types or Puppet classes in one of the modules, you need to change all the other modules that depend on it at the same time. And at the moment, where we have it in just one big Git repository, that's a little bit cumbersome, but it's doable. I mean, you can change the Apache module, for example, and then in the same commit, you can just change every other module that uses the Apache module to use the new API, so to speak. But if we're splitting them out into different Git repositories and like moving the review process to different feature teams that are responsible for different Puppet modules, that of course becomes very tricky to force them to, like, I mean, if one feature team wants to do a backwards incompatible change, they would need to force all the other teams that are using their modules to do a corresponding change at the same time across multiple different Git repos. And I mean, that just doesn't fly. So what this system does is it's using the Puppet Forge, and it creates a Puppet environment per node. So instead of having just like a single Puppet environment that all the nodes run against, you specify what modules you want installed on this particular node. We're thinking of doing that using Hyra, but it also supports getting that as parameters from the external node classifier. So for example, on a playlist node, you might specify that I mean, all playlist nodes should have the playlist Puppet module, and every single node should have the common Puppet module. And then all those modules, of course, have a lot of dependencies on other modules. Like, I mean, the playlist module might depend on monitoring, that sort of stuff. So this system would then dynamically pull all these dependencies in and construct a Puppet environment in a directory on disk, and then run Puppet against that environment for this particular node. So what that allows is that, I mean, one module can depend on the Apache module version 1.x, while another node depends on the Apache module version 2.x. So different nodes can have like conflicting module versions on them. Of course, you can't have conflicting module versions on the same node, but then if you release a new major version of one of your modules, you can like gradually update all the other modules to use this or depend on this new major version instead of having to do it like a big bang change. So that's a plugin that's I mean, it's a node terminus plugin for Puppet, but in reality it just calls another node terminus, so it's not doing any like node classification. It's just that's just a good place in Puppet to hook in and do these kind of module installations at the correct time. But it also consists of a bit more advanced Puppet Forge implementation, and that one because we want the same kind of workflow where you can make feature branches in the Git repositories and run Puppet against those feature branches to test out your changes. So this more advanced Puppet Forge, it supports like kind of multiple Puppet environments that each correspond to a Git branch. And if it can't find the module you requested in that repository or that environment, it will just fall back and look in the production environment. So that also allows us to do kind of partial denormalizations. As it is now, I mean, if you switch a node to run against another Git branch, it will switch every single module to be on that Git branch. But this allows you to switch like, I mean, you can create a branch on one of the Puppet modules, but all the other Puppet modules on that host will still continue to run against the production branch. So, I mean, if for example, then the playlist feature team are trying out some changes with the playlist module on their hosts, us people in infrastructure can still do kind of infrastructure changes and have them actually applied on the playlist nodes. Because at the moment, I mean, if nodes are switched to other Git branches, those Git branches aren't really getting any updates. So if they're denormalized like that for longer periods of time, they need to kind of constantly rebase those Git branches and that sort of stuff to keep up with the updates in other parts of the Puppet repository. This isn't deployed just yet, and we haven't open sourced it just yet, but we're gonna do that very soon, hopefully. At the moment, the code is there, but it's missing some documentation and that sort of stuff, which is probably useful for people to have. As I said, the code is done, and we've been running it in some proof of concepts, and it works quite well. But we have a whole lot of tooling also to do around like actually building these Puppet modules in the CI system and pushing them out to this Forge implementation and setting that up in all the different sites and kind of probably r-syncing between them and that sort of stuff. So that's it for me, but I'm going to move over to questions. Yeah.
You mentioned you're sharing your repository with like over 200 people. Are you doing anything to separate out like passwords and SSL keys and stuff, or does everyone get all that?
Yeah, at the moment that's a little bit, we're a bit bad at that, so pretty much most people get that. We are, it's a bit of a work in progress, but we are making a kind of a different repository for that sort of stuff, which is going to be a higher data. So it will be, external from the modules. It's kind of tricky though with the security mechanism in Puppet that, basically as we allow any developer to push to a feature branch, and then we allow those developers to run nodes against this feature branch. For example, Ruby templates in Puppet or custom functions or that sort of stuff. That's just Ruby code that gets evaluated on the Puppet master. So in that case, if we had a malicious developer, they can basically execute any Ruby code on the Puppet master. So anything the Puppet master has access to could really be accessed by any developer in that scenario. Of course, I hope we don't have any malicious developers. Then we have a lot of other problems as well. But of course, it's not really a good scenario either way to have like checked out versions of a lot of passwords and stuff on lots of laptops.
That's just traditionally been why places I've been hasn't rolled it out to all the developers because we don't want to give everyone using it.
Yeah, it's definitely a valid concern, but I mean, there's ways to, for example, have separate Hierodata repositories and keep them a bit more protected. Yeah.
You mentioned on one of the slides about masterless Puppet, but just before that you said that the scaling of the masters wasn't a problem. Are you looking at the masterless in terms of the test environments? Or?
Yeah, for test environments and also for like building images and image-based deploys and that sort of things. But also, for example, for Vagrant. I mean, for Vagrant and testing in the CI system, that most of those frameworks pretty much depend on doing it masterless. And
we're doing something similar. We do basically a kickstart build, and the kickstart itself installs the Puppet client, and then the first thing the box does when it comes up is check it with the master and get the config that way.
Yeah.
If you see any particular advantage to masterless in the production environment itself.
I mean, the advantages of masterless, I mean, it's, of course, there are some scaling advantages, but on the other hand, you get into more code distribution issues that, I mean, at the moment, for example, as I said, we have like Gerrit doing push replication to the Puppet masters, and that probably wouldn't be able to handle like push replication to 5,000 nodes with all the Puppet manifests. So then we would need to do some entirely different setup for doing that, but we wouldn't need to scale the Puppet masters. But at the moment, as I mentioned, also the Puppet masters are doing some lookups to the inventory system and that sort of stuff, and actually even LDAP lookups. And then there's some libraries and that sort of stuff that we only need to have on the Puppet masters. At the moment, like we don't need the Ruby LDAP libraries on the clients. But if we were to do masterless and still keep those LDAP lookups, we would need to deploy more dependencies like that to the clients.
So one thing we've kind of struggled with is changing from one state to another, since Puppet is just kind of like do this state. Have you encountered that problem, say like upgrading services to a different version or something where you have to stop a service, do some kind of change and start it? And we just found that's kind of difficult for Puppet to do because it doesn't know where you are in any given point necessarily, just know where you're going to be. I don't know if that makes sense.
Yeah, it makes sense. I mean, you can specify like ordering relationships in Puppet to make it do stuff in certain orders. Like, I mean, typically you'd probably want to install the package and then do the config file and then restart the service or start it. And that's fairly easy to model with Puppet, I'd say. I mean, one of the trickier things is if you have that type of stuff across lots of nodes that you need to like deploy new versions across many nodes and do it in certain orders. But then, I mean, there are ways to do that kind of stuff with like exported resources and Puppet DB queries and whatnot. But I think that's just cramming more things into Puppet than what's necessary. And I think it's probably better to use some kind of orchestration framework on top of Puppet to do these kinds of like multi-node dependencies and deployments.
Do you guys use anything like that, like in collective?
Not yet. We're looking into it, but at the moment we're not actually using any real remote execution framework. I mean, yeah, we would like to, but you can get quite far with parallel SSH stuff as well, actually. Yes.
So, are you actually deploying like the Spotify applications, like stuff outside of the OS with Puppet? Is that?
Yes.
Are you actually, and so are they? So are your developers also managing the configuration of those applications through Puppet?
Yes. Yeah.
So
Yeah. Yeah. I mean,
can you explain a deploy? Like go through like a simple deploy of, like one of your applications then?
like when we deploy a new version of the application, or I mean, it actually depends a little bit on the different the teams. They do things a little bit differently. I mean, some specify like specific versions in the Puppet manifest, and then build a new version and like change the version that Puppet is gonna install, and then I mean Puppet will do the upgrade. Some teams just do kind of ensure latest on the package resource in Puppet, and then when you are building a new package, like if you're pushing to the stable branch and the CI builds a new package, that pretty much constitutes a deploy, because then Puppet is gonna upgrade all the servers within half an hour.
I'm just waiting for the latest package, and when it shows up, hey, time to do the deploy.
Yeah,
Is that how you do it?
for some services, that's how we do it, but not for all of them. I mean, it really depends a little bit on the service. I mean, for some services, they have more kind of strict requirements on doing like gradual, slow rollouts and that sort of stuff. I mean,
How do you
we
manage that?
so,
Just to wrap my head around, ensure the latest package is there.
Yeah.
For those that want to actually control the release, do small releases, how do you do that through Puppet?
I mean, in some cases, we just have like an ensure installed, and then they do it pretty much like using SSH and apt-get upgrade on different hosts. On some places where we want to do gradual rollouts, I mean, it might also, I mean, sometimes these newer versions might need new configuration as well. Then we abuse this kind of Git branches that they map to environments. So we basically just switch Puppet environment gradually on hosts as we're
statically defined. Is that a fair statement?
no, and the Puppet environments map to Git branches.
Right. So,
So.
maybe I'm not understanding right. That's fine.
Yeah. Okay. Yeah, we use that like to sometimes to do that kind of gradual rollouts, but sometimes we do just package upgrades kind of out of band from Puppet. So Puppet just ensures installed, and then we use just other tools for upgrading hosts gradually. So it really depends a little bit on the application and what requirements they have. Because I mean, some of the applications, especially those, for example, that use kind of indexes and might have a lot of stuff in their cache and that sort of stuff. So you can't just restart all of them at the same time, because then you're like clearing the cache on all of them, and then you'll have a meltdown. So yeah, you need to like do it very gradually. And I mean, sometimes, of course, as well, you just, in case there's some new bugs introduced, you might not want to deploy it on all your systems at the same time. You might want to like deploy it on 10% first, and have kind of like a canary cluster or canary systems. Yeah. Sometimes through the branches and environments, sometimes through other means. The different teams are doing it in bit different methods. Yeah, I think we, well, if there's any more questions, we might have time for one more, but otherwise that's it. Thank you.